Assalamualaikum warahmatullahi ta'ala wabarakatuh, and very good day to all my beloved students. This time we will learn how to solve the problem related to the second law of thermodynamics, specifically Carnot heat pump. This is the selected question. A heat pump is to be used to heat a house during the winter. The house is to be maintained at 21 degrees C at all times. The house is estimated to be losing heat at a rate of 135,000 kJ per hour when the outside temperature drops to -5 degrees Celsius. Determine the minimum power required to drive this heat pump. This is the recommended step of solution to solve the problem. Firstly, sketch and extract the data of heat pump. Secondly, calculate the coefficient of performance heat pump reversible Carnot, which denote as a COP, HP reversible equal to 1 over 1 minus TL over TH. And finally, calculate the power required to drive the heat pump. Step 1. Sketch and extract the data of heat pump based on the available information from the question. This is the basic component of the refrigeration system or heat pump system based on the desired output. In this case, our desired output is the QH, refer to the heat pump. The compressor, as we know, to increase the pressure and temperature, condenser, to remove the heat, expansion valve as a pressure dropper, as well as to reduce the temperature, and evaporator to receive the heat. We can simplify this diagram by having this one. Warm environment. The component of the refrigeration system or the heat pump can be simplified at this small circle within at the HP heat pump and the core refrigerated space. We also can simplify this diagram into these sketches according to the question. For example, the warm environment refer to the house. Heat pump will remain the same with the work net in, and the cold refrigerated space refer to the cold outside based on the question. And do not forget to insert the value or information from the question, such as TH equal to the 21 degrees C, TL equal to the -5 degrees C, and in QH. We will use these sketches to solve and assist us to solve the entire problem related to the heat pump. Based on the available data or information, we calculate the coefficient of performance of heat pump reversible. We do assumption. For this case, the system operates steadily, and then we insert all the information by using the COP, HV, REV. COP refer to the coefficient of performance, HP refer to the heat pump, REV refer to the reversible. When we use the REV or reversible, we can use the relation of the equation from Q to the T or temperature. For this case, TL and TH refer to the TL and TH. Don't forget to convert from the Celsius to the Kelvin. And after the calculation, we obtain the answer is 11.3. Second step, calculate the coefficient of performance of heat pump. Based on the available information from the question, COP-HP equal to the desired output divided by the required input. Desired output, required input, which is QH and work net in. And then finally, after the simplification, we obtain 1 over 1 minus QL over QH for COP-HP or heat pump. And then knowing the Carnot, we can use the relationship between the Q and T or heat and temperature. So we can substitute the QL for TL and QH for TH. Bear in your mind the remark of the reversible refer to the Carnot. And then straight away we insert all the information from the TL and TH, and of course do not forget to convert from Celsius to Kelvin, and we obtain the 11.3. Final step, calculate the power required to drive the heat pump based on the available data from the question. Bear in your mind, to solve most of the question related to the second law of thermodynamics, either reversible or Carnot or not, you need to be provided at least two information. Okay, in the form of the temperature, or maybe in the form of the work, in the form of the Q. So for example, this one, work net in QH, and COP-HP reversible, which calculated previously. So with these two information, and do not forget to convert in the form of the kilowatt to obtain the final answer 3.32 kilowatt. This is the question, more or less the same with the previous one. Hopefully you guys can try to do this by your own to strengthen your understanding related to the topics. So also provide the final answer for this question. Work net in equal 361 kilowatt. Hopefully you guys get the benefit of this question, and all the best. Thank you.